Today we're going to talk about the quadratic formula, and this is something that's kind of a big deal. So make sure you're paying attention, you have a calculator for sure, and let's grab our binders. So again, let's go ahead and get started right away.
So a long time ago before all of us, people only knew how to solve using factoring, square roots, and completing the square. There was a couple mathematicians that were sitting around a table and they're talking about this completing the square process and how repetitive it is. So they figured there's got to be a way that we have a formula, we can figure out a formula, derive a formula to make this process a little bit easier. So then came the quadratic formula. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So this equation, this formula gives us solutions to any quadratic equation in standard form, as long as it's in standard form. So again, it has to be equal to 0. So we have an a, a b, and a c. So this b squared minus 4ac, this is what we call the discriminant. So this tells me about my solution. So when we see this, we understand if the solutions are going to be real solutions, imaginary solutions, or irrational. Irrational being a decimal that's repeating again in no specific form. So when we look at that determinant or discriminant, excuse me, then we can figure out again if I have the real, if I have imaginary or irrational. So this formula again comes from the completing the square process, or the completing the square process that we do in class when there's a bunch of different steps and we have to figure out how to solve all of those. Except we're not having to show all those steps. It's smaller. There's just a couple steps we have to show. So let's see how this looks when we use it on an example. So again, the quadratic formula can be used to find any of our solutions. So here's a quadratic given to us that we could easily factor using our guess and check method. But just for the sake of getting used to the quadratic formula, we're going to use it to solve this one instead of factoring. So we have to first determine what is a, b, and c. So if I come over here, I can say that a equals, well, that's the number in front of my x squared, so that'd be 1. B equals a positive 2, and c equals a negative 8. So all of these letters we're going to use to plug into this quadratic formula I have on the right. So we're going to start with x equals, and again, the quadratic formula helps us to find our solutions to this quadratic equation. So a negative, and whenever we plug something in, we're going to want to use parentheses. So a negative, my b value is 2, plus or minus the square root of b, again, use those parentheses. B is 2 squared, minus, whenever you plug something in, use parentheses, 1, and c would be a negative 8, all over 2 times a, which is 1. So from here then, we're going to want to go about and simplify it. So I get negative 2 plus or minus the square root. 2 squared is 4, minus 4 times 1 is 4, times a negative 8 would be a negative 32. So I'm subtracting a negative 32, so that would mean the same as adding. Now you can also look at it as if you're multiplying a negative 4 in all these instead of subtracting. Again, all over 2 times 1, which is 2. So if I were to take it again another step, and the more practice we get, there's some steps in here that we can skip. 4 plus 32 is 36, all over 2. So if I bring this work up here, I would have negative 2 plus or minus the square root of 36 we know is 6, all over 2. So now we got to think about where we're getting those two solutions, because this exponent of 2 tells me I better have two solutions. The two solutions comes from this plus or minus in here. So I can rewrite this as negative 2 plus 6 over 2. And I can also rewrite this as negative 2 minus 6 over 2. So when I do this one on top, I get 4 over 2, which would simplify to 2. And my second solution would be a negative 8 over 2, again simplifying to negative 4. So my two solutions should be negative 4 and a positive 2. Now notice, because of my discriminant in here, because of this 36 being a nice number, I got real numbers back. So this one could be factored by guess and check, but we're using the quadratic formula to get in the habit of plugging numbers in and where they go in this formula. So let's try another. So example 2, if you look at it and you tried to use guess and check wouldn't work. This one is going to end up not being factorable. So then our next thing, we could do complete the square. But complete the square has a lot more steps. So instead, I'm going to use the quadratic formula. So when I need to use the quadratic formula, the first thing we should decide is what A, B, and C are. So A here is going to be 1, B is going to be -6, and C is going to be 7. So then I can go ahead and plug it into my equation or my formula. Negative, again, whenever you have to plug in for a letter, use parentheses. I'm going to plug in a -6 for B, plus or minus the square root. Again, I'm going to use parentheses because it's B squared minus 4, A is 1, and C is 7. All over 2 times A, which is 1. So after I plug it all in, now I can go ahead and start simplifying. So negative times a -6 is going to be a +6, plus or minus the square root. -6 squared is 36. And then I have a -4 times 1, which would be -4, and a -4 times 7, which would be a -28. All over 2 times 1, which is 2. Again, 6 plus or minus the square root of 8 all over 2. Now if you notice, there should be a red flag in here that the square root of 8 can be broken down. I can break it down into a perfect square that goes into it, which would be 4 times 2. The 4 then is going to become 2, and I'm left with 2 square roots of 2. So this should look like 6 plus or minus 2 square root 2 all over 2. Now if you notice, every single term here, this term, and my bottom term are all divisible by 2. So I'm going to take a 2 out of all of them. I can't work with this 2 underneath the radical because since it's under the radical, it can't work with anything outside of the radical. So I'm going to have 3 plus or minus, the 2 is going to turn into a 1, so you can put the 1 there, 1 square roots of 2 all over 1. But I don't need to write the 1's either, so we could also write this as 3 plus or minus the square root of 2. And again, the two solutions are coming from this plus or minus, so you can leave it like this, or you can separate it into 3 plus the square root of 2 and 3 minus the square root of 2. So again, those two solutions are coming from that plus or minus. So I will take either or, however you'd like to write it. It might save you some time to leave it as just 3 plus or minus the square root of 2. All right, example 3. Again, we'd want to get it into standard form first. I can only use my techniques with standard form. So the first thing I'm going to want to do here is to move everything to the left-hand side. So it's going to be x squared plus 2x plus 7 equals 0. So then I would want to try my guess and check because guess and check's a lot faster than anything else. So guess and check here, if I were to guess and check what multiplies to give me 7 but adds to give me 2, we'd realize that it's not going to be factorable. So once it's not factorable, then I can either use complete the square or the quadratic formula. You're going to want to know how to use both, but again, you can use either or. Again, without all the steps, since we're learning about practicing the quadratic formula, I'm going to start by using the quadratic formula. So again, we want to figure out what my A is. A is going to be 1, B is going to be 2, and C is going to be 7. I want to pull the numbers from this equation because this is the one that is in standard form. So when I figure out what all my letters are, then I can go about starting to plug them in. So I'd get negative, my B value is 2, plus or minus the square root of B, which is 2, squared, minus 4 times A times C. So again, every time you plug something in, you want to use parentheses, all over 2 times A. So now that I have it all plugged in, now I can go ahead and start simplifying. So negative 2 plus or minus the square root of 4. Then I have negative 4 times 1 would be negative 4, and negative 4 times 7 would be a negative 28. Again, this is all over 2 times 1, which is 2. So again, we can go further and start simplifying, or continue simplifying. So I get 4 minus 28, so I get a negative 24 all over 2. Again, this should cause some red flags because first off, we don't want that negative in there, so I can take that negative out by doing a -1. And I can also split 24 up into a couple more perfect squares. So the perfect square that goes into 24 would be 4, and 4 times 6 would give me 24, excuse me. So then this one's going to change to an I, the 4 changes to a 2, and the 6 will stay as the square root of 6. So this all becomes -2 plus or minus 2I square root of 6 all over 2. Again, if you notice, all these terms are all divisible by 2. We don't want to worry about the 6 because the 6 is under the radical and the other ones are not. So we only worry about what's outside of that radical. So if we were to simplify this, I would get a -1 plus or minus I, because it would be 2 divided by 2 is 1. I'm not going to write that 1. So I square root of 6. And again, it's all over 1, but I don't have to write it. So this would be my final answer. Again, you could separate it. You could do -1 plus I square root of 6 and -1 minus I square root of 6. So you could do either or. It just saves you a little time to leave it as plus or minus. And again, because of this discriminant, this -24 over here, we were able to determine that we were going to have imaginary solutions. So what we mean by imaginary solutions is these solutions aren't going to necessarily show up on your graph. So the picture of this quadratic might not go through that x-axis, but we'll find that out in the next unit when we talk about graphing quadratics. So if you have any questions, make sure you jot them down. I want to thank you for taking good notes, and I will see you in class.